Okay, Ryan, you're not in your assigned seat. You're not allowed. You're not allowed to sit next to Lacey. I don't know. Let's see if I tell him to do something else, he'll do it. Yeah. My wife's big on April Fools. I'm not. Nobody's done anything to me today. I guess that's good.
And I was worried about going, and she was like, I don't know, he didn't tell me, and he already packed my suitcase. I was like, have fun. And she's like, April Fool's. Okay. That's all. I know.
So I have finished grading the tests. Now, Taylor hasn't taken the test yet, so. Oh, you did take it yesterday? Oh, okay. Wonder who. Oh, okay. You did take it. You're right. I haven't graded your test yet. So as far as Rockbridge is concerned, I will post the grades before I leave today, and then I'll send them off to you. I haven't graded everybody's test. Anybody who's taken it in the last couple of days, I haven't gotten around to it yet. I did curve it heavily. So theoretically, if you got 0, if you didn't get anything right, you still got a 40. So that helps. If you think if you failed it miserably, you have less to make up to pull your grade back up. And the next chapter, chapter 12, is going to be a project, which is there is no reason why you can't get 100 on it if you spend a little time and effort. So that'll help pull up your average if you didn't do that well. So I didn't curve. I curved it a lot, but the average is still in the 70s, which normally I don't like to have that low an average, but because you're going to pull that up on the next grade, then it'll average out okay. It's kind of, I was talking to Mr. Appel about. Well, I was talking about how terrible you guys did with probability, and he goes, "Yeah, when I do that, teach that, usually it's 2 grades lower on average." So he's not. Well, I'm not the only one that struggles with you guys learning probability. So I will give the test. Well, yeah, I'll give the test to Hannah. Not Hannah in Rockbridge, but Hannah here.
Thank you.
Okay, so let's. Okay, so let's. Okay, Ryan. Pay attention. Okay, so we started in section 1 about statistics, and we spent most of the time talking about histograms, and we went through this example of taking this data and classifying it into these 7 different classes, which are basically ranges of data. And once you classify all the numbers, you add the numbers up, and you get a number associated with each class, and you can then create a frequency versus quantity graph. And we like to have 5 to 7 vertical bars. In this case, we had 7. We also created this somewhere here. There was a table. I thought there was a table somewhere. Maybe I didn't make the table up. No, I didn't. So let's talk about that. So before we move on to the next topic here. So this is what's called a histogram. There's 2 other things. One's called a frequency distribution. And the other one's called a relative frequency distribution. And they're very similar to each other. And they are basically tables of the information that I presented in a graphic form. So I'm going to make a table up, which is going to be 8 by 3, I think. Yeah, 8 by 3. 8 rows, 3 columns. And the first column is the class. And the second one is the frequency. And the third one is relative frequency. So the class is just the classes I chose earlier, which was the range of numbers. And again, we make, if possible, we make the classes the same width. So those were our 7 classes, which included everything from the lowest number to the highest number. The relative frequency, or the frequency, is just the numbers that I have in my histogram. So the histogram is the graph of basically the frequency distribution. And then the relative frequency is kind of like probability. It's a you know, I was trying to remember whether it's decimals or percentage. I think it's percentage. Let me look it up here. So I'll make sure I get it right. Yeah, well, they actually show it as either a fraction or as a percentage, so either way is fine. So what you do is you add up all the values for the frequency, which should add up to be 30 because I had 30, I think, right? Did I have 30 or 30? I think that's right. Must have more than 30. So 3 plus 8 is 11. 11 plus 16 is 27. 37, 40, there's 50 of them. Okay, so there's a total of 50 data points. And it's always the sum. So if I go back to my table here, I had 50 data points. So I base the relative frequency, it is a percentage. So all you'd have to do is you take the frequency of the individual class divided by the total number of data points. So you'll get 3 over 50, and you'll get 8 over 50. 50, not 15. And 16 over 50. And 13. No, you could actually just do it as either one would be fine. I'm just showing you both ways. So you can either do it as a fraction, or you can show which, you could also do a decimal. So I'm going to do the decimal, and then to get to the percentage, just multiply by 100, or you move the decimal point by 2 points. So this is going to be 0.06. This is going to be 0.16. This is going to be 0.32. This is going to be 0.26. This is going to be 0.14. This is going to be 0.04. This is going to be 0.02. And if I did it right, these should add up to be 100. Let's just see. 22, 52, 54, 64, 74, 74, 80, 94. Yep. So that is, if you add all those up, that's what the little sigma stands for. You get 1, like probability. And the way you could think about it is, if I took all these original data points and I wrote them on a piece of paper and stuck them in a hat, and then I drew a number out of the hat, so I'm randomly picking one of these 50 numbers. If I took these numbers, these would be the probability that I would pick a number between 100 and 104. This would be the probability that I would pick a number between 105 and 109. So these could also be thought of as probabilities, but really all they are is they're basically saying that 6% of the numbers are between these 104 and 100 and 104, 16% between 105 and 109, and so forth and so on. So that's, and when you do the homework, when they ask you to do a frequency distribution and a relative frequency distribution, what they're looking for is a table like this. When they ask for the histogram, they want that. Well, yeah, you'll have to find it just like I did here. So you find the frequency by setting up, this is the part where you find the frequency. So they'll ask you to do that. So basically what the first couple of homework problems are, they'll give you a list of numbers. You have to do this first, then add them up, and then put them in the table, add the total number of however many points there are, divide this by the total number, gives you a decimal or a fraction or a percentage. They're all the same. And when they ask for a histogram, then you'll do that. The final thing they ask for is a frequency polygon. And all a frequency polygon is a histogram, but instead of using bars, you use lines. So if I were to draw the frequency polygon, it would look like this. I just draw a line from each class, the middle of it, and the height. So the height, the position here is the class, and the height, just like the height of the bar, is the value. So it's just a line plot instead of a bar graph. That's the only difference. There's not a whole lot. So if they ask for frequency polygon, I could just show this line separate. I'd plot the points. I'd plot 3, 8, 16, 13, 7, 2, and 1, and then I'd draw straight lines between them. And I guess it looks like a polygon if I went straight down here and over like that. But so those are the four. Yes.
On the line, the red line you just drew, couldn't you get rid of the bars and turn it into a line graph?
Exactly. That's what I was saying. So yeah, I just didn't draw it again because I was lazy. So but if you didn't have the bars there already, you could just draw the line. But since I already had them all set up, it was easier for me just to draw the lines and not have to erase anything. Normally you don't necessarily show both of them, but I'm just doing that to save a little time. Okay, so those are all the things we're going to do. Now I'm going to show you how you're going to do it for your project for this semester. I know you're not going to be able to follow everything in detail, so I put together a video which basically goes through what you have to do. You just have to use your numbers instead of the numbers I use in the video. But otherwise, all the steps are the same. So if you know what you're doing, you just do it. If you don't know what you're doing, you open your computer up, and you have one window that has the video that I record, and the other one you have your spreadsheet open, and then you just look at the video and do it. It's just a one-for-one kind of thing. So don't worry if you don't catch everything. I'm not going to go super fast, but you're not going to be able to write everything down and understand what's going on. So just pay attention to get the general gist of what we're doing.
And is the video going to explain what we do in the project?
Yes. That's why you shouldn't get, there's no reason why you can't get 100. The only thing that changes is the values of the data, but everything else stays the same. Okay, so there we are. So you, to get to your Google Docs app, your Google Apps, you just go to your Gmail and you click on the Apps little button up here. And we're going to go to Sheets. Now what you'll get for your project is I will email you the data, so you won't have to even enter it in. You just have to manipulate it. So I have set up here for me to demonstrate today it's a spreadsheet with a lot of data in it. So it's actually the data that we used. We just used. So we should get exactly the same results here, but you'll see it's a lot quicker than if I have to do it by hand. So you'll see that I have in column A, I have 50 numbers. The same 50 numbers we just did manually. So if I go through here, you know, I'd find that the smallest number is 100 and the largest number is 134 somewhere. Yeah, 134. Okay, so that'll already be given to you. The second column is we're going to put in information in relative to the classes that we choose. So remember, the lowest class was from 100 to 104, and you don't in Google Docs you don't specify a range. You specify just a number, and I'll show you what you have to do, and then I'll explain it to you. So I put in these numbers. So what it's going to do is it's going to look through that list of 50 numbers, and it's going to count how many of them are 99 or lower. So that's what it's going to do for use the first number for. The second one will say how many of these numbers in column A are between 104 and 99.00001. Okay. This one will tell me how many. Then it'll go to the next number in the list. It'll say how many numbers are between this one and this one. So it uses the previous number to tell me what the bottom part of the range is for my class. In this case, it's saying anything less than 99. So you'll choose the classes similarly with the data. You look at your data, you'll see what the maximum and the minimum is. You'll break it up into enough classes that you have at least 5 classes, but not more than 12. And we don't have to, it figures out automatically what to do. Okay, now on Wednesday, I was working with this add-on which had not been added on. So I'm going to show you how you add on, and I'll explain it in the video again too. But if you click on add-ons, I've already got one add-in, but if you don't have this add-on, the way you do it is you click Get Add-ons, surprisingly. Huh? And you search for histogram. And it will list the add-ons that do histograms. And the first choice is this Excel Miner Analysis Tool Pack. So I've already chosen it, so what it would normally do is say free. You don't have to pay for it. So you click on that, and it'll install the add-on. So I don't need to do that because I already have it. But that's how you would get it. So what it means when you go to your add-ons tab, you'll have Excel Miner Analysis Tool Pack. If you've not added this on, you won't see anything. But once you add it on, it'll be there. There's an add-on in Excel called Data Analysis Tool Pack. And if anybody wants to use Excel, I can show you how to get to that. But for right now, I'm just going to do this. So you just say Start. And what it does is it comes up with this little menu on the right-hand side. And it gives you a whole bunch of tools that you can use for statistics. A lot of them most of them we're not going to use. We're going to actually use just 2 of them in our project. The 2 that we're going to use is descriptive statistics. What that does is it gives you all of the information like mean, mode, median. When is it due? Yeah, I haven't assigned it yet, so it's going to be due probably a week after I sign it. So it's going to be a couple of weeks before you actually get to the project. Just work on your homework in the interim. So it's nothing I've got to teach you before you can do the project. Okay, so there's descriptive statistics, which gives you a lot of information. And what we're going to do is histogram. So you click on histogram, and it has just a few menu items you have to fill out. So the input range is the data. So my data is in column A. And the way it works here is you highlight the data and then you click in the little box. So I'm going to highlight cells A1 through A50, which is all my data. Okay? So then you go, while it's highlighted, you go over here and you click inside things. So it says the input range is cells A1 through A50. The second says the bin range, which is, the bin is another word for class. So I go to the, I don't know why I did that. Let me go back here. Because I was scrolling the wrong place. This is the bins. So I'm going to highlight the bins, and I'm going to click in there. And so it's the classes are cells B1 through B8. And then finally, we're going to do chart output. If you don't do the chart output, it basically gives you the frequency distribution. It doesn't give you the graph. And you say OK. Oh, something was wrong. Oh, I have to put the output. So the output is going to be right here. And you don't have to put a range. You can just put one cell. It'll figure it out from there. OK, so that's it. That was a lot easier, wasn't it? OK, so what it's done is it has come up with this, oops, right here. It has a column which has the bin number. The numbers is basically repeating what we have here. And then it has the frequency numbers. So it says there are 3 numbers between 104 and 100, basically. There's 8 between 109 and 104. And if you compare that, we'll just do a quick look back here. We had 3, 8, 16, 13, 7, 2, and 1. And so we got 3, 18, 16, 13, 7, 2, and 1. So that is the relative frequency distribution. Now, there's one thing. It always looks at more than the highest number. It says there's 0 more than the highest number, which I already knew. And there are none that are less than 99. So there's 0 less than 99. Okay, so that's the frequency distribution. Now, the graph is right here. And it already looks pretty good. It's got the bar graph. It's got some labels. It's got a legend which we really don't need, which we'll get rid of. And the class here is not that instructive, so I'm going to use a different labeling down here to be more representative. Also, it uses up some of the space to do the lower and the upper, meaning lower than the smallest number and bigger than the biggest number. So let's show you how this works. So I can get rid of these two here by going over and just deleting the first and last row here. So if I take this and I push delete, notice the graph redoes itself and gets rid of the bottom little bit. If I delete that, then it gets rid of the top part. So now there's not stuff in there I don't need. So that's good. The next thing I'm going to do is I'm going to write in the legend, or not the legend, but the axis information. So really I have 3 that are between 100 and 104. And then I go 105 to 109, 110 to 114. And then I've got, then I go from 115 to 119. And this is very much more obvious about what they stand for, instead of just single numbers. So what I want to do is I want to use those as my axis descriptors, my data descriptor, rather than what I have originally. So now we're going to go over and we are going to edit the graph. So you go up here and there's a little triangle and you go Advanced Edit. So we can put a new title in. So I'll say histogram of some random data. Okay, whatever your graph, you can be a little bit more descriptive. And if you click anywhere outside of that box, it'll change it over here. We don't need a legend because it doesn't really help us any, because we only have 1 bar. Then you can go down, you can change the horizontal axis title. I'll say some random number. So that's there. You can change the size, the color, all that kind of stuff. The only thing we really have remaining to do is to change the range here. So what it's done is it has automatically decided what I'm plotting, which is the first column the C column was the numbers that define the bins. So I really want to use column E instead of column C, because column E is the one which I just created. So what I can do is I can manually go in here and change C to E. So I'll use a different column. And I got rid of the first and last rows, so I can change those to 2 and 9 instead of 1 and 10. What that's doing is it's getting rid of the two rows, the one that was less than 99 and the one that was more than 134. So it's only looking at the ones that have data in it. And the second thing I'm doing is I'm getting data to describe my ranges here instead of by a single number, by a range of numbers. So that looks like it's good. So I go update, and there I am. So that's my graph. The vertical axis is the frequency, which is appropriate. My histogram is called histogram of some random data. And my labels here are very plain about what I'm showing. I'm showing how many numbers are between 100 and 104, 105 and 109, etc., etc. So that's done. That's pretty much what you're looking for when you look at a histogram. Now the last thing is you can easily change this from a histogram to a frequency polygon. And so the second tab was the kind of chart you have. So if I did it this way, it would look like what I just told you. But if I just wanted the line by itself, then I'd have that. So that's the frequency polygon. This would be the histogram. I don't know where, there's no line, so I'm not sure why that isn't the case. But anyway, so that's a histogram. That's a frequency polygon. All I'm doing is replacing the bars with the line. So that's it. Okay. All your homework you're going to do by hand, but then you'll do this later in the a couple of weeks or so, maybe 2 weeks. And then what you do is you'll save this and you email it to me, and I'll look at it. Okay, so we're done. We're done on that part. So hopefully everybody thinks they can do that once they have more instruction. So don't worry. Usually what happens is the people who don't do well is they wait till the last minute and then they don't have time to come and see me. So don't wait till the last minute. Oh, sorry. Went to the wrong place. Okay, there we go. Okay, so we just have a few things left. Stem and leaf displays. This is something that I asked my other class, do you remember doing this? And you said, yeah. I mean, you do it a number of times in high school. So I'm not going to spend a huge amount of time. I'm just going to remind you what they are. And we're going to take the same data, and I'm just going to show you how to construct a stem and leaf plot. So I need to get my data down here so I can. Okay, so here's my data again. So kind of like with classes, what you do with a stem and leaf plot is you usually draw something that looks like this, and then you have horizontal lines that just make it into a semi-table. And I need 6 of those, I think, 6 lines, maybe 7 lines. So the column on the left-hand side is basically the first 2 numbers of the data point. So we have 100 to 104, so this one's going to be 10. So I can write this I'm going to write this down. You normally wouldn't write this down, but I'm just showing you what I'm really doing here is we're looking at these ranges again. So the first 2 digits of these numbers is 10. This is 104, this is 18, say. Then you'd have 2 for 11, for 112, say, and 118. Then you'd have for 2 for 12s, 120. and then you'd have your 130th thing. So this has a special name, and I forget what it's called, but it's like a dual leaf plot, because you're going to use two of these have the same starting point, but what I'm going to do is I'm going to put the ones that are from 100 to 104 here, and the number you write down here is just the last digit. So 112 would go right here, because I have 1, 1, 2. This one, 100, would be 1, 0, 0. And 128 would go in this one, because this is from 120 to 124, so that's to 128. So you'd write an 8 in there, so 128. 120 would go there. 134 would go there. And let's just go for a few more here. 118, 106, 110. And we'll do one more, 109. Okay, so you just felt you'd have 50 numbers here on the right-hand side. So it's very similar to what we did here with just marking things out. The thing here is I didn't really care what the number was once I put it in this bin. I just wanted to count how many there were, whereas a stem and leaf plot actually gives you, it's going to give you a histogram kind of thing, you know, depending on how many numbers you have here. It's like a bar going horizontal bar instead of a vertical bar. And you also know the exact data points. So I know this is 106, this is 109, this is 112, 112, 110, 118, 120. So the stem and leaf plot allows you to know more about the specific numbers that are in the data. But in reality, this kind of plot gives you as much information as most people need. You want as little data as possible to understand what's going on, but not so much data that it confuses you. Okay, so there's the homework for this section. So that'll be due next Friday. So pretty much the first four or five problems are creating frequency, relative frequency distributions, histograms, and frequency polygons. So it's what we just done. We did manually on Wednesday and automatically here on Friday. So it's not a lot of problems, but I recorded them yesterday, and it takes a while to do them. So you know, you probably spend about an hour doing those problems. Before we move on to the next section, which is talking about mean, mode, and median, is we're going to just talk about some other types of presenting data. And we've already done this in Chapter 1, but we're going to do it again. So the other ways you can present data besides histograms or frequency polygons is just to do bar graphs in general. I mean, a histogram is a kind of bar graph. You can do pie charts, circular pie charts, and line graphs, which are like frequency polygons. But what I did yesterday in class was I picked some topics that you guys might be interested in, and then we found if we could find a plot and then talk about the plot. So does anybody have any, what's anybody interested in here? What you think might be an interesting topic to look at data from? Sports, okay. Baseball, okay. What kind of baseballs? Major League Baseball. Okay, well let's just put that in and see what we get. Favorite topping on a pizza. Okay, that's probably, you probably could find data on that. Let's see if there was any other suggestions besides Adam. Oh, that was not, okay, so where are we here? Favorite pizza. Okay, so here we are. And so we'll go to Google. And we'll go to images. And well, let's look at a histogram first. So Major League Baseball Histogram. See if anybody has any histograms. Oh, interesting. Oh yeah, I remember this one from last year. So this is a histogram of the temperature during the first pitch of the Major League Baseball season from 1997 to 2012. It violates our rule here because it's more than 12 classes, and you can see how it's kind of busy. So if you look at the minimum temperature is 35 degrees and the maximum is 94. So you would probably, if I were using the rules, I would probably break it up into increments of 5 degrees maybe. And that would give me a more reasonable. What they're doing is they are showing every degree. But one thing you notice is it does have a shape where there's a middle tendency for the distribution. Meaning right here it's the highest, which is also, if you kind of draw a general curve for the whole thing, it's what we would call something that looks kind of like a normal distribution. It has a bell shape to it. It's not exactly bell shaped, but it is greater in the middle. It tapers off at the ends. We know that the average is going to be somewhere around here just by visually looking at it. Even though the max is here, because this is kind of left of center, the average is probably going to be about right there, which is about 64 degrees. Okay, so that's. Okay, let's go back, see what other interesting histograms we can look at. Okay, so apparently this is it's from a statistics course, but it's surprisingly, how about that? It's the frequency distribution for batting average. So notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 classes, and they are separated by 20 units. So 200 to 220, 220 to 240, 240 to 260, and so forth. So that's the bin size. Again, it has this characteristic shape that looks like a bell, so it looks like a normal distribution, just on face value. But it's a little easier to, the last one we looked at had too many bins. This one has a smaller number, but then you can see the average batting average is around 260, and you can see most of the batting averages are between 220 and about 300. And then as you go further away, so let's see what else we can find here. What's this one? Yeah, that's stuff we don't want to talk about. Dental age estimation. What is that? I don't know what that stands for. Okay, let's look at another one. So here's the most common scores in Major League Baseball history. So again, it's not a bell curve because it's kind of skewed towards the lower values, and that happens when that happens with a certain kind of data. It's not normally distributed. I don't know what the little red highlight is. Does it say dark red bars are scores this decade? Light red are scores from a century ago. Okay, so what I think that means is it doesn't mean this little bit is the score. It means that the whole thing is basically showing that scores are going up compared to 100 years ago. The people are scoring on average more runs. Most common score is 3, so this would be 1. Well, this would be 0, 1, 2, and 3. It's most common score because it's the highest bar. Okay, let's remove the histogram from the question mark here. See what other interesting statistics we can find about baseball. No. Oh, I got to put statistics or something here. Graph. Okay, there we go. So this is Major League Baseball team valuations in 2013 in millions of US dollars. So we call this a horizontal bar graph. You could do the same information in a vertical bar graph. Does anybody have any idea why we may do a horizontal here instead of vertical? What would be the problem if I put the New York Yankees in the vertical? You'd have a hard time reading that, right? So if you had it as a vertical, if you're using numbers, if your x-axis is numbers, well, usually you can see in this case it's numbers. So if your quantity that you're trying to classify is a number, then it's probably going to be where a vertical bar graph works best. But if you have the column representing something described by words, a horizontal bar graph probably makes more sense because we write horizontally, and descriptive names can be fairly long. So you'd have to either write New York Yankees at a 90-degree angle, so you have to bend your head. You could write it vertically, but nobody reads words vertically. Or you could, there are other ways of getting around it. But so it's just a matter of, it just looks better because you can write these out more easily than if I rotated it 90 degrees. So that's why you might choose one over the other. They're basically doing the same thing. They're using a bar to represent a quantity. So yeah. So in the interest of equal time here, so here's the soccer clubs. So it's it looks like the same people are doing it because it looks exactly the same. So you've got Real Madrid, Barcelona, Manchester United, and so forth and so on. As you go down, their valuations relative to the football teams. Actually, so I forgot what the numbers were for the Yankees, but the interesting thing here, how many people are interested in soccer? Anybody? Yeah, a little bit. So so the interesting thing is in Europe. I don't know if it's in European, but I know it's in the English leagues. You've got the Premier League, and you've got the Champions League, Championship, and then you've got League One and League Two, and they have this thing called promotion and relegation. And so if you're one of the better teams in the lower league, you get promoted to the higher league. And if you're in the higher league, but you're in the lower end of the higher league, then you get demoted to the next league down. So you have it's kind of like if you're in a band and you're on third chair, third section trumpet, theoretically you can make it all the way to first chair by challenging the next person as you go up and try to do that. Of course, it takes forever, so you never go very far. These teams like Manchester United that have been in the Premier League for tens of years, then you get somebody who's been promoted in the Championship League. They come from a smaller town with less money. So I think what happens a lot of times, most of the time, is somebody gets promoted and then they stay in the upper league for maybe a season or two, and then they get demoted because they just don't have the resources available to buy players, or not buy them, but to pay them sufficient money so they're competitive with the top teams. But here's a specific example. So the area I'm from in England, there is a small town called Burton, and they were in League 2 last year. They were promoted from League 2 to League 1. This year they are leading League 1. So they might get promoted from League 1 to Championship League in 1 year. So it's highly unusual for that to happen, where the lower teams from the lower league, the higher teams from the lower league usually don't do that well in the next league because the competition's more fierce because there's more money in it. So they're if they do that, that's a very unusual thing to go. League Two is kind of also RANs, but Championship League, theoretically they could go to the Premier League, and which would be crazy because the town's not that big, but it's always a possibility. It's kind of like this final. It's like the NCAA tournaments for basketball. Usually the higher seeds win, but every once in a while, like Syracuse, what are 10 seed, they're actually in the Final Four. Again, it doesn't happen very often, but it gives everybody hope that they can actually make it to the Final Four. The 64th seeded team, they're just happy to get in and play one game most of the time. So that's kind of our only equivalent to this whole idea of relegation and promotion. But it's kind of neat because it does allow you to move up in the world. It's a very democratic ideal. Anybody can be somebody if they work hard enough. Okay, let me just switch back here. So anyway, we could spend days talking about different ways graphs are presented, but for right now we're just going to talk about that one. So the next section we're going to cover here is this one, section 2. So we're going to do measures of central tendency, which is you've done before, so we're not going to spend a huge amount of time on it. So there are the three main things. There's mean, there's median, and there's mode. So we'll talk about mean here. So the mean of n data items is calculated as follows, and you use the horizontal bar over top of the variable to show that you're talking about the mean. So x bar means the mean of x. And what you do is you just add all the values up and divide by the number of values. So the mean is just the numerical average of a set of data. And typically the mean is about where the center of the data is, especially when it's normally distributed. This is the number that is most often used for central tendency. The other two, the median and the mode, are used much less, only in special cases. We actually use the median is used mostly for drawing what are called box plots. They're ways of representing the mean, the central tendency, and the distribution in a very simple fashion. We'll talk about that later, but the mean is the one that we use most of the time for talking about that. Okay, so I think we're done. I'm off to see the other grandchild this weekend. We're going up to Alexandria. This is Xander, the 1-year-old. So, had his birthday last weekend. So have a good weekend. I'll try not to get hit by traffic again. Yes. Yes, thank you. I did see you. Thanks for letting me know. I see Lacey disappear. I don't know where she went to. Ryan, where'd Lacey go? Did you drive her out? Lacey left. What happened? Yeah, I know. I'll have to give them half credit for attending since they just disappeared. I don't know what time. I didn't notice what time they left. I just looked up there and like, where'd they go? Maybe they figured since Heather came, they could leave. I don't know. Okay, we're in section 8, or not 8.2, but 12.2. So we're talking about mean, median, and mode. So this is a very long section. I do have a reasonable number of problems. So number 1 says calculate the mean, the median, and mode. And they're already sorted, so that's nice. So we have the numbers 7, 9, 12, 14, 34. So the mean is you're going to add these numbers together. So I'll get my calculator out. So you take 7 plus 9 plus 12 plus 14 plus 34. That's 76, and you have 5 data points, so the answer is 15.2. So that's the mean. The median is the middle number, median. So the middle number is 12, because there's 2 on either side. So the median is 12. And so that's A, this is B. C is the mode, no mode, because they all only have one of each number. Okay, then we got number 5. So we got some more numbers here. I think these are also ordered originally. So we got 3.1, 4.5, 6.2, 7.1. Actually, they're not ordered. So we're going to have to do that at some point. Might as well do it to start with. 3.8, 6.2, 6.3. Let me make sure I got this right. 3.1, 4.5, 6.2, 7.1, 4.5. Okay. So now we're going to order them numerically. So we have 3.1, 3.8. So all we do is you just skim through and look for the next higher number. So 3.8, the next one would be 4 point something. And I've got 2 4.5, so I list those twice. Okay, let's just mark them off as we get them done. Okay, so we go 4, 5. There are none that start with 5. Then we go to 6. So we got 6.2, 6.3. So we got 2 6.2s, 2 6.3s. No, just one 6.3 and a 7.1. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's good. So our mean, again, is you add all those numbers together, and I'll write it down this time. So 3.1 plus 3.8 plus 4.5 plus 4.5 plus 6.2 plus 6.2 plus 6.3 plus 7.1. So the sum, the total is 41.7, and we have 8 numbers. So divide that by 8. I get 5.2. So that's the mean. Now with this listed, we have 8 numbers, so there is no exact middle number. There are 2 middle numbers. We have 1, 2, 3 on this side, and 1, 2, 3 on this side. And then, so what you do to find the median when you have that situation, when you have an even number of data points, then you take the average of the 2 middle ones. So we're going to take 4.5 plus 6.2 divided by 2. And I get 5.35 or 5.4 if we round it off. No, actually they don't round it off. They put it as 5.35. Okay, so that's the median. This one had an odd number, so in that case, it's the one in the middle. So if you think about it, there are 5 numbers. If you divide by 2, you get 2.5. You round that up, you get the third number, 1, 2, 3. So that's how it works when you have an odd number. So if you had 7, you take 7 divided by 2, which would be 3.5, and you add 1, so it would be the 4th number. Now when you have an even number of entries, then you just go to the middle. So we have, in this case, we have 8 entries, 8 values. We divide by 2, so that's 4, and so 4 and 5 are the 4th and the 5th number in the ordered arrangement. You take the average of those 2. So the 4th number is this, 5th number is that. And then the mode is the number there's the most occurrences of, which is 6.2. There's 2 of those. Actually, there's 2 modes. There's 4.5 and 6.2, because there's 2 of those and there's 1 of all the other ones. So the no mode is the most common number. Okay, number 9. Same kind of deal here. Let's write the numbers down. 128, 131, 136, 125, 132, 128, 125. What I'm doing is I'm doing 2 numbers at a time, just because I can remember 2 numbers, and that means I don't have to look back. And then the last one's 127. Okay. So how many numbers? 1, 2, 3, 4, 5, 6, 7, 8. So, is that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that's the case where the two middle numbers, but they're not ordered, so that we don't do that yet. So first thing we do, we just write the numbers down, then we order them. So let's look for the smallest number, which would be 125. And then we look for the next ones. Oh, we have 2 125s. So get those, mark those off. And 126, we have 127, we have 128. Okay, actually we have 2 128s. Then we have 130s, 131, 132, 136. 131, 132, 136. Okay, so they're ordered now. So a mean, we add them together. 125 plus 125 plus 127 plus 128 plus 131 plus 132. I think I've lost my place here. Yeah, there are 2 128s. Plus 128 plus 128 plus 131 plus 132 plus 136. So I get 1,032 divided by 8. 8 numbers. 129. So that's the mean. The median is going to be 128 because these are the 2 middle numbers. So the median is 128. And the mode, there's 2 modes, which is 125 and 128. Okay. And the next one is, did I even need to do that one? I think I did one I didn't need to do. 9 was not one of my problems. I'm doing is looking at the wrong section. Oh, great. Okay, well you got some for free there. Actually, I might just assign them so I'm not wasting my effort here. So we're going to go back. Sorry about that. So number 6, 14,320, 16,950, 17,330, and 15,470. So we're not going to have any mode. There's going to be no modes because they're all different. So the mean is just going to be the sum of those 4 numbers. So I'm just adding them together right now. So I get 64,070 divided by 4 data points. I get 16,017.5. And the median, well, we can't do that until we order them. So instead of ordering, I'm just going to list them. This is the smallest. This is the next. This is the next. And that's the last one. So because there are only 4, it's just the 2 center ones. The ones that are not the smallest or the biggest, but the ones in between, which would be this one and this one. So we take the average of those 2 numbers. Divide by 2. 16,100 and 16,210. Okay. Now we go to 11. So we have a table which lists the number of departures, the number of accidents, and the fatalities for the years 1999 through 2008. And they're asking us to find the mean, the median, and the mode for various things. And so the number of departures, unfortunately, that is not in any kind of numerical order, so we're going to have to order them. And so we're going to look at column 2. Probably the best thing to do is just to write them out, or we can look at the graph and then just write them out in order. So let's just do that. So let's look at the list, and the smallest number is 10.2. And then we have a 10.3. 10.3, only one of those. We have a 10.4, 10.5, no, 10.6. We have a couple of those, I think. 10.6. So we have 1, 2, 3 of those. Okay, 2.7, yeah, we have one of those. 10.8, yes, one of those. 10.9, we have 2 of those. And do we have 11.0s? No, we do have 11.1. Okay, let's count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so at least that's the same number. So now the mean is just adding all those numbers together. So it's going to be around a little over 100 because they're all close to 10, slightly more than 10. 10.2 plus 10.3 plus 10.6 plus 10.6 plus 10.6. We have 3 of those. Plus 10.7 plus 10.8 plus 10.9 plus 10.9 plus 11.1. That's up to be 106.7 over 10 points, which is 10.67. So that, or 10.7 if you want to do it, million. The median, we have an even number again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if we take 10 divided by 2, we get 5. So we want to do the 5th and the 6th numbers. So let's count 1, 2, 3, 4, 5, 6. So because they're an even number, we average the 2 middle numbers. And you can see it's going to be 10.65. We'll round it off to 10.7 if that's what they're looking for. No, they say 10.65 million, and the mode is the one that's most often listed, which is 10.6, because there's 3 of those. So the mode is 10.6. Okay, so we're going to stop there and do another video.